All right, let's take a look at the remainder theorem. And we're also going to do a little bit more division in this as well too. So yeah, we'll look at both things. So first we're going to look at division. So we're going to look at this thing called synthetic division. There's a bunch of instructions here, but we'll just go through it kind of step by step. But essentially it's an alternate to long division. So long division is just an algorithm. It's always the same steps. You divide, you multiply things through, and then you subtract, finding out what's left over, and you repeat that over and over. So we can make this process just a little bit more efficient with this thing called synthetic division. And we'll see how it works, and we'll compare it to long division. Okay, so let's look at x cubed minus 7x plus 9x plus 2 divided by x minus 2. So we have already on our sheets, and on here, the long division process. So it works, it gives you an answer, and we get that. What we can do instead is this thing called synthetic division. So to start synthetic division, we kind of do this L shape. Let's do it again like that. And on the outside of it, I'm just going to put down x minus 2 would solve to, let's say, x equal to 2 if we were to set that equal to 0. So I'm just going to put the 2 on the outside, kind of in that top left section. Okay. What I'm going to do next is I'm going to take that polynomial we have that we're dividing, x cubed, so on and so forth. I'm just going to rewrite it, but I'm just going to write the coefficients, because having to always write x cubed, x squared, x will take a little bit more time. But just looking at the coefficients, 1, -7, 9, and then a 2 at the end, we'll just make things a little bit quicker. And then, again, synthetic division will be an algorithm, but the way we're going to do it is going to make things a little bit more efficient. So the first thing we do is first part is just drop that number 1 down. That's the start, and now we get into the algorithm. So the algorithm is going to just say, take the 2, multiply by the number that we have down there, and write that in your next column. So essentially what we're going to do is we're going to create columns of numbers. And so that's going to be the number 2 here. So 2 times 1 is 2. All right, and then what we're going to do with those columns is we're just going to add the numbers in the columns. So -7 times, or not times, -7 plus 2 is just -5. Okay, and now we repeat the algorithm. So take the 2 that's in front and multiply that by the -5 and write that down in the next column. So 2 times -5 is -10. Add up the next column, so 9 minus 10, and that gives you -1. Repeat one last time because we have one last column to go. So 2 times -1 gives you -2. 2 minus 2 gives you 0. Okay, so what do these 4 numbers at the bottom? This is really what we care about, is the 4 numbers at the bottom. What do they mean? Well, the first 3 numbers, those are your quotient. It's the coefficients of your quotient. And what's going to happen is they're the coefficients, and they're going to be 1 degree less than what we just said. So we started with x cubed. So that's now going to be x squared minus 5x minus just 1. And, well, what's the number at the end? The number at the end, that is your remainder. So you have the quotient, you have the remainder, that's what we need. And if you take a look at what we have on the other side, well, we have x squared minus 5x plus 1, or minus 1, and we also have the same remainder, 0. So it matches up. So at first it might seem like just a bunch of numbers there, but once you, again, get kind of the algorithm down with synthetic division, it can be a little bit more efficient than long division. So it's kind of up to you which you want to use. You can always use long division, but if you want a method that is a little bit faster, synthetic division is great for that, although it can be a little bit just bare of anything that might seem like it has meaning, but it does. It really does. Okay, so let's try another one of synthetic division. And we're going to do one where you have a root that is a fraction. So we're dividing by 3x plus 1. So the corresponding, you can think of it like, what's the corresponding factor, the corresponding x-intercept the root? Well, 3x plus 1 equal to 0. If you solve for x, that would be negative 1/3. Okay, so we do that, and that's going to get us started with our synthetic division. So the negative 1/3, that goes on the outside. And we write down the coefficients of our big polynomial, 3, 10, 9, and 2. And then drop the first number, write that down, and do the steps of multiplication and addition. Just repeat that over and over. So 3 times negative third is just negative 1. 10 minus 1 is just 9. Okay, again. Negative a third times 9, well, that is negative 3. 9 minus 3 is 6. And repeat that one last time. Negative a third times 6 is negative 2. 2 minus 2 is 0. So again, we've got our numbers there. So we have the first 3. That's going to give us 3x squared plus 9x plus 6. And you have the remainder. And actually, at this stage, we're close to being done, but not quite. What's a little bit, since what we're dividing by had a lead coefficient, we're dividing by 3x plus 1, we actually haven't really taken that into account. And you can see, even if we look at our long division, the long division gives us an answer of just x squared. But if we were to do 3x times 3x squared, we would get something bigger than what's in our polynomial. So what we actually need to do, there's one last step. If the thing you're dividing by has a lead coefficient, you just need to divide the polynomial that you get. Divide it by that lead coefficient. So divide by lead coefficient of that factor. Okay, and when you do that, well, let's take a look at what that gives us. That's going to be equal to x squared. What's 9 divided by 3? Well, that's 3x. What's 6 divided by 3? 2. We get the correct answer in this case. And the remainder, you don't have to do anything with that. That is still just 0. Okay. So that's the one thing we need to be careful of. But yeah, synthetic division is a handy and useful tool, which we can make use of throughout the unit. All right, now let's get to this thing called the remainder theorem. So we're going to look at remainders. Remainders are, we're going to find out they're pretty handy. And if we're looking at something like 6x cubed minus 3x plus 2 like you did in the formative, you should have gotten a remainder of 155. And if you did 2x minus 3, it wasn't a nice number, but it's what our calculators are for, 71/4. Okay. So to get those remainders, you had to go through and do that long division process. And with that long division process, it's the final step. Let's just do some other calculations though. Let's just see. So we'll call that polynomial, the one that we were dividing. We'll call that p of x. So we'll have 6x cubed minus 3x plus 2 equal to p of x. And let's calculate p of 3. So if you substitute in 3, 6 times 3 cubed minus 3 times 3 plus 2. Plug it in. Type it into your calculator. The first part's going to be big. You're going to subtract by 27 plus 2. And in the end, you get, confirm with a calculator, 155. Okay, let's do the same thing with p of 3/2. So you'll get 6 times 3 over 2 cubed. Again, try this out on your calculator yourself. Minus 3 times 3 over 2. Yes, there are fractions which are sometimes annoying, but you can use your calculator. And if you calculate this out, you should get, well, 71 over 4. Now, take a look back at what we just had up above. 155, 71 over 4. We're getting the exact same answers. So how are we getting this 3, and how are we getting that 3 over 2? Well, what we're going to see is that how we get that 3 and that 3 over 2 is those are just essentially the roots, the corresponding roots of what we were dividing by. So what we can say is, in general, and this is what we're going to call the remainder theorem, is that if you have a polynomial, p of x, and you divide it by something like x minus b, the remainder will just equal to p of b, as in substituting that number. So we saw up above, when we were divided by x minus 3, sub in p of 3. And what if we have something with a lead coefficient and ax minus b? Well, if you're solving for the root, set it equal to 0, rearrange, and if you rearrange that, you get b over a. And if we saw with our previous example, let's just go up. 2x minus 3, if you rearrange 2x minus 3 equal to 0, you will get x is equal to 3 over 2, which is what we substitute in to get the exact same answer. So the remainder equals p of b over a. And yeah, we're assuming a can't be 0 because you can't divide by 0. But those are integer values. Okay. And we're going to see that we can actually make use of this to eventually do some factoring. That's going to come in the future, though. But yeah, it's a lot quicker than having to go through the whole process of division. Just plug in the number and you can find out what the remainder is. It doesn't tell us what the quotient is, but we can get the remainder just like that. Okay, so let's find the remainder when 3x cubed minus 2x squared plus x minus 5 is divided by x plus 2. So what's handy is just label it p of x, and well, x plus 2, rearrange that, you get x is equal to negative 2. So we're just looking for what is p of negative 2. Well, negative 2 cubed minus 2 times negative 2 squared plus negative 2, or you could write it just as minus 2. All that, plug it in, and we'll see what you get. And in this case, you will get negative 39. So therefore, the remainder is negative 39 by the remainder theorem. Because the remainder theorem says, just plug it in, whatever your factor is, into the polynomial, essentially. Okay, let's try that a couple more times. Okay, find the remainder when that is divided by 2x minus 1. And we're going to keep things exact. So yes, if there's fractions, leave your fractions. Getting used to using fractions in your calculator is also going to be helpful. So this time I'm just going to call this f of x just to differentiate it from the previous one. And so the thing that we want to plug in, well, to figure that out, is just rearrange the thing we're dividing by, the factor, solve for, in a sense, like the x-intercept, the root. And we're going to get 1 over 2. So what I want to do is I want to calculate 1 over 2 when that's plugged into our function. So 1 over 2 cubed minus 4 times 1 over 2 squared plus 2 times 1 over 2 minus 6. Okay, take a moment, plug that into your calculator. Once you substitute that in, you should get something like negative 47 over 8. So just make sure you can get that on your calculator on your own as well too. Okay, let's take a look at this. So when x cubed is divided by x minus 3, well, that whole polynomial, the remainder is 12. So we want to find k. So this is a little bit of a different problem, but the idea remains the same. So we have this polynomial. This time I'll call it p of x. We're dividing it by x minus 3. So we're looking at 3. So since the remainder is 12, we know that when we substitute that number into our polynomial, p of 3, it must equal 12. That's the key thing. That is using the remainder theorem. So what can we do? Well, let's just substitute in 3, just like we did with the previous questions. Whatever you're dividing by, substitute that in. And what we know this time is we know that the left side must be equal, substituting in p of 3 equal to 12, must be equal to 12. So we get 27 minus 9k plus 17 times 3, which is 51, plus 6. And so we're just going to rearrange a little bit. So 27 plus 51 plus 6, that's something like 84 minus 9k. Move the 84 over, you'll get 12 minus 84 is negative 72. And so k is just negative 72 over negative 9. But reduce and simplify your fractions always, and so you get just 8. So there we are, using the remainder theorem in a little bit of a different context to find that missing parameter in our function. Okay. Let's take a look at one last example here. So we have a polynomial. It's divided by 3x minus 1. We know the quotient. So that's the answer to our division statement is 2x minus 3. And its remainder is 4. So what can we do? Well, we can make use of our kind of like our multiplication statement. That's what I'll call it. So the multiplication statement basically says that our polynomial, or the dividend we can call it, that's the thing we're starting with, is going to be the divisor, what we're dividing by, times the quotient, the answer, plus whatever remainder we have as well too. Okay. And let's just kind of match things up with what we're told. Okay, so we know that we're divided by 3x minus 1. So that's the divisor. We know that the quotient is 2x minus 3, so that's our quotient. I'll just write that down as well here. And we have a remainder of 4. So that's kind of the 3 things we have on the right side there. So we can create this polynomial now with this multiplication statement. We can say that we have 3x minus 1, 2x minus 3, plus 4. And I'll call that p of x. We could expand that out. And if we expand it, you'd get 6x squared minus 9x minus 2x plus 3 plus 4. And combining terms, you end up with 6x squared minus 11x plus 7. And so there you have it. That is a look at the remainder theorem, which is a very handy theorem. It works very quickly. And just plug in the corresponding, in a sense, root, you can think of it as, of whatever your divisor is, and you can get the remainder. And not only that, we also looked at synthetic division, a nice kind of shortcut way of doing long division, which can be helpful when you want to go through division a little bit more efficiently.